Welcome to Loksatta Yashasvi Bhava. Children, you have learned a lot about chemical equations, balancing the equations, and have also learned the different types of chemical reactions. Children, just visit the kitchen and see around. You will come across many ingredients that we use for cooking different items. Try tasting a few of them. Maybe all are not possible. You will come across substances which are sweet to taste. Some of them are sour in taste, while some of them are bitter to taste. So those substances which are having sour taste, they consist of the acidic ingredients, and those substances forms the acids. Whereas those substances which have bitter taste, they consist of the basic ingredients or the bases. Now let us learn about these acids and the bases, their properties and different chemical reactions related to the acids and bases. How do we identify the acidity and the basicity of any substance? There should be something to determine the acidic substance and the basic substance. The common example that you have been using till date is the litmus paper. This litmus paper or the litmus solution is being prepared from a natural plant which is named as lichen. There are different types of indicators which are used for determining the acidic and the basic substances. So those substances which determine the acidity and the basicity of any substance, they are called as the indicators. The different types of indicators are the natural indicators, which consist of, they are prepared from natural substances like rose petals, beetroot, turmeric, etc. Then there are certain synthetic indicators. These indicators are prepared from the chemicals, like example phenolphthalein, methyl orange, eosin. These are certain chemical indicators. When we add a drop of these indicators to the unknown substances, they give a specific color change which determine the acidity and the basicity of the unknown substances. Similarly, other type of indicators that we have are the olfactory indicators. These olfactory indicators are associated with the odor. When you add a few drops of olfactory indicators in the unknown solution, they show a change in the odor of the original substance, and this change in the odor specifies or determines the acidic property or the basic property of the unknown substance. And lastly, we have a fourth type of an indicator which is called as a universal indicator. Universal indicator is a mixture of all the indicators put together, and this is generally used in the laboratory. Children, you may have also done experiment related to by using these different types of indicators. So in the laboratory we make use of a universal indicator and also the litmus paper very commonly. Now let us see how to determine the strength of the acid, how strong or how weak is the acid. We all know that acids, they basically consist of the hydrogen ions. So more the number of hydrogen ions in the solution, more strong is the acid. Lesser the number of hydrogen ions, weak is the acid. Similarly, the bases consist of the OH ions. More the number of OH ions in the solution, more basic is the substance or the compound, and lesser the number of OH ions in the solution, weaker is the base. Now to determine the strength quantitatively, we need a method how to identify how strong is the acid or how weak is the acid. This can be, you have used a universal indicator in laboratory for the experiments that you have done. You may have noticed that on the universal indicator bottle there are two things to be observed. One is the color change and besides the colors given, there are numbers associated with it. These numbers are related to the pH scale. The pH scale reads from 0 to 14. So with the specific color change, there is a number associated with it, and then you can determine the acidic property or the basic property of any unknown substance. On the pH scale, the reading which shows 7 shows that it is associated with the green color. When you put a few drops of universal indicator in an unknown solution and it turns green in color, which shows that it has a pH value of 7 and hence it is a neutral solution. Also, the reading which goes from or shows between 0 to 7, those substances are acidic in nature, whereas the readings between 7 to 14, those substances are basic in nature. On the universal indicator bottle, you will also observe that the color changes from green shows neutral, and then onwards the color goes on taking a yellowish tinge, then it becomes orange and then red. That means the color changes. For the acidic substances, the color changes from yellow to orange, from orange to red, whereas for the basic, you will observe that the color change goes from green color onwards, it becomes blue, it takes a bluish tinge, it gets blue, darker blue, and then finally it gets to purple color. So those substances which shows the pH value 14 are the most basic substances, whereas those substances which shows pH scale as 0 are the most acidic substances. So this is how you can determine the strength of the acid or the base. Now let us learn or study about the chemical reactions that take place with the acids and the bases. The first reaction is the reactivity of acids towards the metal. This also by now you are familiar, you have done some of the reactions in metals and non-metals chapter. We will see that most of the metals, they react with the acids to form salt, and hydrogen gas is evolved in the process. Example, magnesium reacts with hydrochloric acid to give magnesium chloride and hydrogen gas is evolved. Similarly, iron reacts with hydrochloric acid to give iron chloride and hydrogen gas is evolved. Zinc too reacts with hydrochloric acid to give zinc chloride, evolving hydrogen gas. So we see that most of the metals, they will react with hydrochloric acid, they also react with sulfuric acid, liberating hydrogen gas and giving the corresponding salt. But again, it is not so in all the cases. Metals like copper, it does not react with hydrochloric acid at all, because it is a very least active element. It will not be able to replace the hydrogen from the acid to liberate the hydrogen gas. But then copper definitely reacts with sulfuric acid, replacing the hydrogen to form copper sulfate, but instead of liberating hydrogen gas, here water is formed in the chemical reaction. So we see that those metals which are less active will not be able to react with the acids, liberating the hydrogen gas. Now let us see what is the reactivity of bases towards the metals. We will see that none of the bases, in fact, they will not react with the metals except for aluminium and zinc. Aluminium and zinc, both being amphoteric in nature, they have the chemical property of reacting with both acids and bases. Hence these are the two metals which react with the bases, forming, like aluminium will react with sodium hydroxide to give sodium aluminate and hydrogen gas is liberated in the process. Zinc reacts with sodium hydroxide, forming sodium zincate, evolving the hydrogen gas. But not all the metals react? This is because scientifically the metals and the bases both, they are the electron donors, and chemically they will not be able to react with each other. Now let us see the reactivity of acids towards the carbonates and the bicarbonates of metals. Example, sodium carbonate will react with hydrochloric acid to form sodium chloride, water and carbon dioxide. Also, sodium bicarbonate reacts with hydrochloric acid to form sodium chloride, water and carbon dioxide. Children, you may notice here that both sodium carbonate as well as sodium bicarbonate, it reacts with the acids, evolving the corresponding salt, water and CO2 is liberated in the process. This happens because sodium carbonate and sodium bicarbonate both are basic in nature, and bases react with acids to form the salt and water. Now let us see the reactivity of acids with metallic oxides. Example, copper oxide is a metal oxide. This reacts with the acid to form copper chloride plus water. Here copper chloride is the salt, H2O is water. Therefore, can we conclude that copper oxide, that is the metal oxide, is basic in nature? Why? Because you know, in neutralization what happens? Acid reacts with the base to form salt and water. Hence we say and you also are familiar that metal oxides are basic in nature. So bases react with the acid to form the salt and water. Now, do you feel that these basic oxides will react with any bases like sodium hydroxide or potassium hydroxide? No. Why? Because copper oxide being basic in nature and any other base, these both cannot chemically react with together to give a new compound. So this chemical reaction is not possible. Now let us see what is the reactivity of bases with a non-metallic oxide. Let us take example of a non-metallic oxide like carbon dioxide. Carbon is a non-metal and its oxide forms a carbon dioxide. Now here the base will react with carbon dioxide to form calcium carbonate and water, that is the salt and water. Again in this reaction we see that a base, that is calcium hydroxide, combines with CO2 to form the salt, calcium carbonate and water. Hence we conclude that carbon dioxide is an acidic oxide. Now again think whether carbon dioxide can react with the acid, and the answer is no, because CO2 itself is acidic in nature. It will not react with any other acid to form the corresponding compound or the product here. Now from these two equations or the reactions, let us conclude that the reaction of acid with the base. Acids always reacts with the base to form the corresponding salt and water, and these reactions are called as neutralization. Example, hydrogen chloride reacts with sodium chloride to form NaCl plus water, and this reaction is a neutralization reaction. Children, there are some more things to be studied from this chapter, which consist of the units like ionization, and we are also going to study more about the common compounds or the common salts that are there, their physical properties and chemical properties, which we shall do in our next video session.